thank you all so much for joining here today for our conversation about our new report, Bringing Clean Energy Home. On the next slide, before we get started here, a few introductions so that you know who's on the line today. I'm Lauren Schweisberg. I'm a manager in our carbon-free electricity program here at RMI. I'll be starting us off today with a brief presentation before we move into Q&A. I'm joined today for our Q&A by two of my co-authors on this report, Mark Dyson, who's a senior principal in our carbon-free electricity program, and John Kreitz, who's a managing director and our chief program officer here at RMI. I'm also joined today by Rebecca, a senior director on our development team, who will moderate our Q&A. Once again, thank you all so much for joining us this afternoon. It's all of your support that makes our work here at RMI possible. For those of you who are unfamiliar with RMI, a quick introduction. We're a 501c3 nonprofit headquartered in Colorado with the mission to transform global energy system to secure a clean, prosperous, zero carbon future for all. To do this, we're doing two things in 5 places. So first, we have teams focused on driving decarbonization in 4 critical sectors: electricity, mobility, buildings, and industry. We also have teams that are focused on strengthening market catalysts that cut across these sectors. Across these topics, we have teams working on implementation and policy on the ground in 5 key geographies: China, the US, India, the Global South, including the Caribbean, Sub-Saharan Africa, and Southeast Asia, and cities. So moving on to the topic that you've all come to hear about today, we're talking about our report, Bringing Clean Energy Home. We're going to dive into several topics today: the role of US households in the energy transition, the challenges we face in decarbonizing our homes today, the opportunity for new products and services to make decarbonization easy, and the role that regulators and utilities can play in supporting these new solutions. There are a few key takeaways from our work that I'm going to emphasize up front. The first is that home energy solutions can help address a critical piece of the decarbonization puzzle and help the US meet our climate goals. The second is that new solutions like Google's Nest Renew, whose features we analyzed in this report, represent a promising first step towards unlocking more options and a lot of impact for households. Finally, that an ecosystem of products and services that is supported by policy and regulatory structures has the potential to really create transformational change. So before we dive in deeper into these insights, I just wanted to share a funding acknowledgement. RMI was invited to assess the impact of a service like Google's Nest Renew and independently offer this report to address how the service and other home energy solutions can contribute to ambitious climate policy targets. So at RMI, we've been focused for a long time on innovative and scalable approaches to drastically reduce greenhouse gas emissions consistent to a level with limiting warming to 1.5 degrees Celsius. And we often work with private companies as part of that who are testing new approaches to accelerate progress in entire industries towards deep carbon emissions reductions. So we accepted an invitation from Google to do this work with that goal in mind. Google provided funding for this research, and we're really grateful to the Google team's thought partnership in thinking through the opportunities to decarbonize households across the US. The findings that we'll share today were independently derived by our team at RMI, and RMI is solely responsible for the views that we're going to share. What we'll share today here with you is our own analysis, except for one slide where we'll share a description of Google's new service, Nest Renew, to provide context for our analysis of the impact of a service like it as we lay out in our report. So let's get into some of the key takeaways in more detail. First, that home energy solutions can help address a critical piece of the decarbonization puzzle. So on the next slide, our motivation for this work really stems from the fact that about 40% of US energy-related emissions are connected to decisions that we as individuals can make about energy use at the household level. As you can see in the top part of this chart, about half of that comes from our homes directly. And on the bottom of this chart, you can see that the part that comes from our homes directly includes electricity to keep the air conditioning running or our lighting and appliances on, and natural gas burned directly in our homes for space and water heating. The other half comes from personal transportation, like cars and personal trucks. So on the next slide, we looked at how we are doing on reducing those emissions. And the bottom line is we're not currently on track in the residential sector to reduce emissions in line with economy-wide targets. So the US currently has a target to reduce emissions across our economy by 50 to 52% by 2030 from 2009 levels, which is shown here by the black arrow on the far right of this chart, from the dashed line representing 2005 levels down to the solid black line representing a trajectory that would meet those commitments. When we look at the share of current emissions attributed to the residential sector, shown in teal, without new policy intervention, we expect that they'll fall on the dotted line about 20 to 30% from 2005 levels, which is short of a 50% reduction that would be in line with the economy-wide climate targets. Fortunately, we know how to tackle big pieces of this large challenge. So the good news is we already have several options to address them and make progress in this decade. First, we know we need to accelerate system-wide electricity decarbonization through the deployment of carbon-free electricity, like new solar and wind power, and through demand-side management, like energy efficiency and demand response, which can help avoid the need for new fossil power plants. Second, we know we need to tackle the direct emissions from building and vehicles in our homes. So on the building side, we can do this by deploying building retrofits that minimize energy use and emissions associated with heating and cooling, and by accelerating electrification, such as by installing high efficiency heat pumps. On the vehicle side, vehicle electrification or equivalent mode switching, like using public transit, can help avoid the use of internal combustion driven vehicles. So if we can help households deploy these existing solutions, it can help us meet the US's ambitious climate policy goals by 2030, that target of reducing CO2 emissions by 50% from 2005 levels. We took a look at what some of the types of adoption numbers are that support that target. The scenario that we laid out in our report included a 10-fold adoption of energy efficiency technologies, doubling demand response program enrollment, doubling the amount of carbon-free electricity delivered to homes today, growing the share of electrified homes by 50%, and scaling the electric vehicle market by nearly a factor of 100. So there are a lot of different pathways that could get us there, but these numbers can help us contextualize the level of ambition that we're talking about here. But this level of adoption is actually really hard to imagine today. On this slide, we've outlined an illustrative process for a customer who wants to adopt a new technology in their home, say a heat pump. First, you have to locate the options, do research, call contractors. Second, they have to figure out how to pay for the upgrade, locating incentives and rebates, assessing cost savings, perhaps sharing meter data for contractors to provide a more detailed estimate, and finally go through the installation process, which may require upgrades to plumbing and electrical, inspections, and maybe even changing a utility rate to optimize savings. That's a lot of steps. And throughout this journey, we kind of boiled it down to 4 key barriers that households face. So first, solutions are limited. Many households simply don't have access to options that can materially reduce emissions. For example, I'm a renter. Renters like myself can rarely make the case to install significant energy upgrades. Next, solutions may be costly. The reality is that many energy upgrades come with a high upfront cost, even if they do save money over time. Third, solutions are complex. as we've laid out here, reducing emissions can be a multi-step process, and even individual steps like finding the right contractor can be enough to dissuade someone from moving forward with an upgrade. Finally, solutions are very fragmented. In most cases, households do this whole flow chart, this whole process independently for each upgrade that they're trying to pursue, which misses the opportunity to capture the benefits of a coordinated or more bundled approach. So next, I want to talk a little bit about emerging solutions and their potential. So in response to those barriers, we're starting to see some solutions providers, regulators, and utilities identify strategies to address them. So we've outlined here some principles for emerging solutions that we're starting to see emerge. First, we see the opportunity for solutions that are targeted. For example, recommending to households exactly the kind of solutions that will work for them and for their home. Second, we're seeing an opportunity for solutions to be more affordable. For example, by providing free services that optimize energy use, or by seamlessly surfacing local incentives and rebates. Third, we see a potential to shift to more simple solutions. For example, by streamlining the process of identifying options, making signups easier for clean energy programs, for example. And finally, we see an opportunity for solutions to be more integrated, breaking down silos across technologies and utility programs, and integrating resources in homes more seamlessly with the operation of the grid. Solutions providers that apply these principles can really help scale some of the adoption and help us reach closer to those targets that we shared earlier, the level of ambition that's required to meet our climate targets. So to understand the potential carbon impact of the emerging solutions on the market, we analyze the features of a service like Google's Nest Renew. So to provide you an accurate description of the service and its features, we provide here a description of the product, which we've derived from Google's own description. To learn more about Nest Renew and its features, please visit Google's blog and website describing the service. A brief overview of Nest Renew, starting with Nest Renew Basic. Nest Renew Basic will be free to join. Some of its features will be visualization of the grid's carbon intensity, which you can see in the mockup on the right. Energy Shift. Energy Shift will help Nest thermostat users automatically shift their HVAC use to times when the grid is cleaner. Renew also brings in signals on carbon emissions and electricity pricing together to make it easier for customers to automatically prioritize using cleaner, cheaper energy throughout the day. And then the final feature is the Energy Impact Program. So through actively using Nest Renew, users can earn leafs. And as they hit leaf milestones, the Energy Impact Program will allow them to steer their support towards community nonprofit projects across the US with partners like Grid Alternatives and Elevate. A brief overview of Nest Renew Premium. Nest Renew Premium will be available in select markets for $10 a month. It will also include a Clean Energy Match feature. And with Clean Energy Match, Renew is going to purchase renewable energy credits to match the estimated amount of fossil generated electricity that a home consumes. Google's released a white paper called Supporting a Clean Energy Future with Nest Renew, which describes the carbon targeted REC procurement approach that's going to support projects in more fossil intensive grid regions, which they will deploy with the premium subscription. So we analyzed the features of this service like Google's Nest Renew at launch to start to understand the potential carbon impact of emerging solutions like this on the market. In summary, we found that the features of a service like Nest Renew could support demand response from set point shifting, energy efficiency from seasonal adjustments to thermostats impacting heating and cooling, and carbon-free electricity. The demand response, energy efficiency, and carbon-free electricity that could be supported could reduce emissions from an average home by about 30%, or result in an annual reduction of about 5 million metric tons for 1 million homes. So finally, I want to talk about what happens with significant adoption of home energy services and what this ecosystem of product and services could unlock. So there's an opportunity first for home energy products to go deeper and really address more of a household's emissions. So looking forward, we looked at 4 additional opportunities for features of a home energy service that could nearly triple emission savings, which are shown in the middle 4 bars here on this graph. So together, these opportunities could lead to over 80% of carbon emissions reductions for an average home. So first, citing wind and solar in fossil-intensive grids where they can reduce the most carbon emissions would increase the impact of the carbon-free electricity supported by a home energy service. Second, expanding demand flexibility to other loads beyond air conditioning, for example, to heat pumps, to EV charging, could save almost 1.5 million more tons of CO2 on an annual basis. Next, we looked at the impact of a home energy service that's able to successfully support deep retrofits and building electrification, perhaps by connecting subscribers to qualified contractors or using customer data to streamline identifying the right appliances and interventions for our homeowners. And finally, we looked at the impact of supporting households to make the switch to an electric vehicle or otherwise reduce the equivalent of one household vehicle through mode switching. We're really excited to see more service providers start to tackle these deeper pieces of household emissions in a meaningful and scalable way. So finally, we looked at the big picture. How might household decarbonization products and services contribute to meeting the annual emissions targets that we're looking at in 2030? We found that if 10 million households adopt a product or service that supports just demand side management and carbon-free electricity, they could address about 7% of the gap between today's household energy emissions and the 50% reduction in annual emissions that we're hoping to see by 2030. So that's about the number of customers that are participating in residential demand response programs today. With further regulatory shifts that unlock innovation, solutions providers could help households dramatically reduce their emissions. Reaching about 50 million households with an offer of the expanded scope that we described on the previous slide could fully close the gap between household emissions today and 2030 clean energy policy targets. Finally, there's a lot of work to be done here by solutions providers, by utilities, by regulators to unlock this opportunity. So we offer 3 main actions that utilities and regulators can take to accelerate adoption of household solutions. First, adjusting utility incentives and processes to maximize integration of demand-side resources. What we mean here is finding ways within the utility business model to ensure that utilities are motivated to support households to make this transition. This means looking at performance-based regulation, ensuring planning processes are designed to maximize demand-side solutions, and updating outdated cost-benefit frameworks, as a few examples. Second, aligning residential programs, incentives, and rates with household benefits. So there's a real opportunity to consolidate the current universe of incentives, programs, and rates with different qualifications and different sign-up processes into a more manageable set of households, to a more manageable set of options for households with clear trade-offs and clear benefits. Finally, enabling data access and transparency. There's an opportunity to reevaluate the types of information that innovators in this space need to build a business while balancing customer protection and privacy. And to make sure that the data that we're currently collecting, such as AMI data, is being used in a way that can support households to decarbonize. So that's it for my overview of our research, and I'm going to hand it over to Rebecca now, who's going to lead us through Q&A.
Thank you, Lauren. We are going to start with a moderated Q&A where I'm going to ask our panelists a set of questions, but then we are also going to have an audience Q&A. So please feel free, if you're new to Zoom webinar, there is a Q&A box that you can use to add your questions. And please let us know if you guys have any trouble with that setting, because we're definitely excited to hear from our audience on this one. So the first question I have for all three of our panelists, I'd love for you to share a little bit about why this report has been personally important to you, and what are some of the challenges that you have all faced in decarbonizing your own homes?
Thanks, Rebecca. I'll kick it off for us. So I'm a homeowner. I'm very motivated to reduce CO2 in my home, and not just as part of my day job. So I took some steps over the last few years to do that, right? I signed up for my utilities green tariff that let me support a new build solar project near my home. But then I moved and my utility unsubscribed me from that program without notification or recourse. So in my new home, my next step was to invest in an air source heat pump. I created my own spreadsheets and navigated a maze of utility and local incentives. And after dozens of hours, I didn't get any of those incentives. And the heat pump, though it works great, doesn't work with any of the other smart technology in my home. So I was excited to explore, as part of this report, solutions that could help other people not have to jump through all the hoops that I went through over the past few years.
Yeah, and I've had an experience quite similar to Mark's, though, as I mentioned in the presentation, I'm a renter. So I am a renter in a pre-war apartment in New York City. I have radiators, I have window AC units. So I enrolled my window AC units in a demand response program, which was discontinued a year later, much to my dismay. I've also tried to navigate the universe of signing up for carbon-free electricity through retailers or through community solar program. And similar to Mark, it's been a process of making my own spreadsheets and really deep research to try and figure out what my cost savings or monthly cost addition is going to be from subscribing to some of those options. And then finally, I've tried to do this with my parents' home as well. My parents are homeowners in California. I subscribed them to their local green tariff. It was supposed to save them money. A couple months later, they got an email saying rates are going up and it was actually going to be at a net cost to them. So these are the types of challenges that we've encountered as people who like making spreadsheets to try and figure out our cost savings, and can only imagine how to navigate this with less expertise.
Yeah, and I wish I could say our experience in my household was a resounding success, but similarly, true to the page that Lauren presented earlier, there are just a set of barriers that you face every step along the way. Even something as simple as changing our entire house to LEDs set also all fluctuations through our electricity system in the house that cause lights to dim erratically and cause all sorts of problems there. But then you get into elements around drilling in our backyard. We found out we have a giant bed of basalt that was going to require special rock drills and way up the cost in order to put in a ground source heat pump. Our HVAC contractor said that our radiant floor heating was not compatible with smart thermostats, and that there would be significant changes that had to be made at the structural level to our heating system. So it's not easy. And again, for Mark and Lauren and I, this is our passion. This is what we want to figure out how to do. And the idea of not having an easy button that we can all press and just say, we want to decarbonize, help us do that, has been really frustrating, because we know many folks out there don't have anywhere near the perseverance or desire and need the tools to really access clean energy in their homes.
So given all of those challenges, Mark, I'd love to hear from you on how you see that Nest Renew and products and services like it, how can they help?
Well, I think the place to start is with the principles that Lauren laid out in her presentation. Services like Nest Renew display many of those principles, or aspects of many of those principles that can be critical in helping us all bring clean energy home. So for example, Nest Renew or services like it can provide options that are targeted to individual households' needs. They can provide options that are simple to sign up for to help consumers save money or choose clean energy without day-to-day management. They can offer affordability through free services or through targeted finding of financing solutions for homes. And then, I think it's also important to recognize how services like Nest Renew and others can be integrated into utility programs to maximize the impact that households can have at the scale of the grid. So we see a material potential for impact and also for addressing some of the barriers that we all encountered from a service like Nest Renew and others.
Excellent. Thanks for that, Mark. John, I'm really interested on your take on what does it take to make this type of a business into a climate solution? What kind of an ecosystem of service providers do you think we need?
Yeah, well, I mean, clearly, based on Mark's description, we do need an ecosystem, right? There is no single individual, no single company that can solve this on their own. And for it to be relevant for climate, to Lauren's numbers, we need to get to 50 million houses, with deep energy savings here over the next decade to really be on track for 1.5 degrees. And I think that all puts a premium on really developing a network approach that has really 4 different layers of coordination and collaboration within it. And we think about the need for the customized insights for each of us, right? That helps meet us in our apartment or our house or a place of residence. That helps tailor and allows us to see both what the options are that fit our needs, but also where the incentives are and the relative prices that allow us to understand what we can do. Secondly, we need the types of companies that help us understand the automation and optimization of that. And that's an area where those providers of demand response and others can help us, kind of intervene, something that we can set up with a smart thermostat or otherwise, and simply have everything done for us in the end. And to think about how Lauren's house or Mark's house relate to my house and coordinate that across so the grid ultimately gets the better answer in the end. Third, we think about how do you aggregate everyone's demand, right, across 50 million houses so that we get the lowest cost possible for the heat pumps available, for the shifts that are required in kind of charging infrastructure, et cetera. And so there's an opportunity for how do we aggregate and create markets from collective desires, right? And finally, there's that element of deployment innovation, right? If this is all just about mom and pops, kind of figuring it out for themselves along the way, we're never going to build a scalable industry in the time required. And so we have to think about how do we build out, large-scale contracting services that are available and neighborhood suite programs and things like that allow us really to tackle this issue with the vigilance and with the importance and the coordinated response that's really required for us to be on a track for 1.5 degrees. So those 4 big areas are really how we think about it. And a platform like Google's is really interesting because it pulls all 4 different pieces together. But Google doesn't do it on their own, right? They need different levels of support from everyone along the way. And we would also say Google is just one of many providers that can step in to fill this gap of coordination. And we're eager to see a vibrant market develop for each of these different services and believe this is just emblematic of a whole series of changes that are likely to come.
Thanks, John. Lauren, I'm switching over to you. Given this ecosystem that John's describing, what do you think the role is for utilities? How do we get them on board with the types of solutions that John's describing here?
Yeah, it's a really good question, Rebecca. I think there's a lot of opportunities for both leadership and partnership with utilities when we talk about innovative home energy products. So many utilities already have goals that they're finding difficult to achieve around deploying energy efficiency, around deploying demand response that could potentially be accelerated by partnership with an entity that can make things really compelling for customers or really easy for customers to sign up and get more enrollment in these types of programs. Utilities also might have decarbonization targets, and households can be a leverage point in accelerating progress towards those goals with more support for clean energy. I think it's really important in general to just find those areas of mutual benefit where there's opportunity for both an innovator to make progress and for the utility to be able to provide households with something that will truly benefit people.
Mark, what type of progress are you starting to see on the depth of these business models? Like, how do we transition towards solutions that touch a deeper set of emissions in the home?
Yeah, well, I'll draw back on what Lauren presented earlier, and I'll bucket into the same two categories. A business that goes deep into decarbonization for a home will do two main things, right? It will support consumers in touching more sources of emissions, like heat pumps, like EVs, and it will, second, deeply integrate with utility programs or electricity markets to make sure that the carbon-free homes that we're helping to support are also the building blocks of carbon-free grids, and thus support the decarbonization of the whole energy system, not just, within the four walls of a home. And I think we're seeing progress on both of those fronts, right? And it's exciting to see. We've seen businesses specializing in deep energy retrofits for homes. What we often see is that they're focused in a given region or on a given segment of homes, but it's exciting to see examples spring up all over the country and internationally, because that means that we know that there's lots of ideas coming up and that kind of approach can really scale. And then on the utility side and the integration side, we're seeing some utilities in partnership with developers and solution providers really go deep, right? And actually demonstrably avoid constructing a new gas-fired power plant, for example, by relying in part on customers' own demand response assets or energy efficiency or deep energy retrofit upgrades as part of a clean energy portfolio that together actually lets the utility not build a power plant or retire an old coal plant. So these are the kinds of things, and again, we're seeing examples pop up all over the country that give us hope that businesses and utilities working together can go deep, and that this kind of solution can actually reach 50 million plus homes in the next decade.
Thank you. One last moderated question from me. This one's probably for Lauren. As you three are all very aware, RMI is really committed to a just and equitable energy transition. So were there concerns that this type of solution would only be available to well-off customers?
Yeah, absolutely, Rebecca. But I think what we're seeing is that there are also a lot of opportunities within products like this to think really deliberately about what a just and equitable energy transition looks like and really support a just and equitable energy transition at scale. So one of the features that a home energy service like Nest Renew or others could unlock, as Mark mentioned, is deep energy retrofits and electrification, which today carry a really high upfront price tag and don't necessarily have a well-defined supply chain or contractor network. So there's an opportunity there to help people locate the incentives that are already available that can buy down the costs, or even drive down the cost of the whole supply chain for all customers, making it less expensive for everybody to electrify. There's also job opportunities in building out those contractor networks and local community benefits, such as what Mark was just mentioning. If you can avoid a gas plant in your community, there are health benefits at stake for communities. So at scale, there is a lot of potential here in terms of making these types of upgrades accessible to more people and accessible to the communities that really need them most, especially when we're starting to think about the health of homes and bill savings that could be associated with adoption of many of these solutions.
Excellent. Thank you so much for that. And thank you all for answering the questions so far. We are going to switch over to the audience Q&A section. Our team has been collecting the questions as they've come in, and I will start running through those. So we've had quite a few questions around blockchain and RMI's market affiliate, the Energy Web Foundation. So John, I'd love to hear from you about whether blockchain is going to play a role in interconnecting or gathering all of this data. And then specifically, will Energy Web Foundation be involved in any way?
Yeah, no, thanks. We, at RMI, we recognize kind of the interesting ability of blockchain to operate a decentralized network alongside a decentralized grid here. 5 years ago, we started researching and thinking about that, and we built out Energy Web as the result. And Energy Web, kind of using blockchain, does provide some unique benefits and opportunities for us here. I would say there's not one individual technical path here going forward, but there's a lot of intrigue and interest still around blockchain, and we're working in the Energy Web on a deployment in Australia that's really large, that's looking at how exactly do we make a fully transactive grid where you have machine-to-machine balancing and wallet-to-wallet clearing that's all automated, right? And so the grid's running itself and running demand response and using batteries in a dynamic way that takes a lot of the personal decision-making out of it, right? Which is fascinating, and it's still in the early stages of implementation, but we're monitoring it very closely and think that's one of a range of solutions that can be used. I think here in the United States, there is an implementation that's gone on with CalISO, specifically on digital identifiers for individuals and the preservation of the integrity of individual accounts that can all subscribe to emergency response for the California wildfires or otherwise. And there's a unique ability to kind of preserve confidentiality through blockchain-based mechanisms that allow people to opt to participate in the market without the broader market knowing and being aware of that. But there's a balance to be struck here between having a centralized company know more about you and kind of help manage and optimize data for the grid versus you having complete control over your data and volunteering that where you want to into auctions or otherwise. And I think, we'll see both of those models emerge. The former is more of kind of what Google is helping to build out, which is this kind of highly collaborative but centralized approach. And the latter, where kind of more bottoms up, is much more suited to a blockchain environment. I think we're going to see a merger of these two very clearly here going forward as we think about how the grid evolves and what the prospects are for managing and dynamically clearing a grid that is really where every asset on the grid, whether it be a battery, whether it be a heat pump, or whether in the end it be a decision that you're making around whether or not to set your washer to run at a certain time, all of these become integrated into a larger balancing mechanism, not just for electrons, but for carbon molecules and their emission into the environment.
Excellent. Thanks for that, John. So another question we have, Mark, this one's probably for you. Many split heat pumps are currently left out of the market to participate. Does Google Nest have any solutions? Flare Puck is one, but it is not networked like Nest.
Yeah, so I agree with the statement that mini split heat pumps are a big part of the solution, and I think are an important opportunity available to many households to lead to material carbon reductions, my own included, right? In my story about my own decarbonization journey, that was a mini split. I can't speak necessarily to the integrations across the whole space of thermostat providers, but I do know that that's one of the most important things to get right going forward is interoperability or integration between the various kinds of hardware. And by hardware, I mean things like heat pumps, things like EV charging equipment, things like hot water heaters, that kind of hardware, the integration between big energy using devices and the intelligence and the customer experience that can optimize the energy use of those devices with the decarbonization objectives of the home and also the flexibility requirements of the grid. So that's probably one of the most important things for us as an industry and a stakeholder community to get right as soon as possible so that these assets can start playing a bigger role in both homes and on the grid.
Excellent. Thank you. So the next question is regarding another of RMI's market affiliates, WattTime. WattTime specializes in estimating and predicting marginal carbon emissions, which is critical for demand response. Is there a hope for fine-grained data from utilities to become available about which sources are on and how much they emit so that we don't have to keep guessing from the outside?
Yeah, absolutely. That's a really good question, Rebecca, and I can take that one. Excitingly, Nest Renew, which we described in their energy shift feature, will actually be using WattTime data as one of the inputs for data shifting. So to read more about that, you can also look at the sources that I described there. But we're seeing broad interest in more marginal emissions data and finer grained marginal emissions data really across the industry right now. PJM, for example, has their own data now, and we're seeing a lot of interest from corporate entities using similar data sets to decide where to locate their renewables projects in order to have the most impact as well. So not only WattTime, but a suite of solutions that we're seeing emerge across the board, and a lot more interest in understanding how we can both shift load and site projects to reduce marginal emissions.
Thank you, Lauren. Another question we have from the audience: utilities have the ability to identify energy usage per square foot for commercial and residential customers. Should there be targeted tax incentives or subsidies to the utilities to reduce usage of the top 75 percentile to 5 to 7% a year? And this could potentially be able to help with integrated energy savings programs.
I'll comment on that one, Rebecca. I think the example that you gave here that came from the question is a good one of different policy structures or incentives that can line up the incentives for utilities to really want to reduce carbon and reduce energy use at the right times and in the right ways that supports broader grid decarbonization. And there are many more, right? I think, the recent news and ongoing saga of policy in Washington right now. I'll use a rough example there, where in policies that, like the ones that are under consideration around Clean Electricity Performance Program or others, where we're considering ways to incentivize utilities to reduce carbon, we always need to be thinking not only of the supply side, but of the demand side as well, and ensuring that it's not just building new wind farms and new solar farms and new batteries that can access incentives, but also saving energy when it's the most valuable, or when saving it saves the most carbon. And so there's a need, I think, and this is a very specific example of a way to do that, but more generally, to balance incentives on the demand and the supply side, so utilities have every tool in the toolbox and work with their customers to meet ambitious climate goals.
Next up, we have a clarifying question. One of our audience members was confused about the inclusion of EV chargers in household carbon reduction. So if you don't use an EV, then are your emissions, energy use part of the transportation sector rather than buildings?
Yeah, definitely, Rebecca. That's a good clarification. For the purpose of this analysis, while you would normally see the residential sector as residential electricity use and buildings, direct use of fossil fuels, we also included personal transportation here, which is normally housed in transportation sector inventories. And the reason we did this is we really wanted to paint a full picture of the emissions that a household would have in their control. And the reality is that we choose whether we drive an EV or not as individuals. And most households do at least own one vehicle for personal use. So we wanted to include that as part of the picture and part of the decision-making process that households have within their control.
Excellent. Another of our audience members had a question around how could they go about setting up test projects at the neighborhood level? Mark, is that something you could speak to?
Yeah, so this is a really exciting idea, right? I think the promise of reaching 1 million households is amazing. And the promise of reaching 100,000 households or even 10,000 households in a very concentrated area is just as exciting, because they can have a commensurately greater effect when household demand is concentrated within a certain distribution feeder, a certain region of the grid, even just within a certain utility. So this idea of rapidly and with focus scaling adoption within a given neighborhood can access so many more opportunities for cost savings and carbon savings. For example, avoiding upgrades to a distribution feeder or delaying them, or, as we've alluded to over the course of this conversation, leading to a retirement decision or an avoided build decision for a local peaking power plant that would create serious pollution during the times of the year when it run. So right now that we see that as a huge opportunity, and we see slow movement, I would say, over the past few years from the utility industry and its partners, and actually realizing that vision, because it's hard, right, to drive adoption at that level in a concentrated area in a way that works for everybody. But because we have seen some successful examples in California, in New York, in Utah, in Colorado, I do believe that it's the kind of idea that both can scale and needs to scale to fully access all of the benefits of this kind of approach for decarbonizing homes.
Excellent. Thanks, Mark. John, I'm going to flip back over to you, because we've gotten quite a few additional questions around blockchain, energy web, watt time. So those include, does watt time run on energy web? Is Cal ISO going to use energy web in its tech stack? And then the software of Nest does it use blockchain to track the green energy, and how do they know what energy is green without a direct PPA for each customer? So we'd love to just kind of get your thoughts on those questions and the blockchain more generally.
Yeah, so, and I hope I didn't sow any confusion with my prior comments, but Energy Web is doing things independently from Nest Renew here, and is not, kind of fundamentally the tech stack that's being used there. Nor is Energy Web necessarily the tech stack underneath Watt Time, right? They're each managing separately. Cal ISO, though, does have is using the Energy Web technology specifically for its emergency response system right now. And that is especially to identify unique assets and unique accounts where they can call upon those assets when needed to respond to emergency situations on the grid. So that's kind of the clarity there. I think, Google has been working, and I turn this over to Mark Dyson to comment as well after I make a few remarks. But Google has been working on how exactly do they track and ensure that there is a reasonable kind of alignment of your interest with clean energy and available RECs that are in the market, and have been, I think a key innovation or leadership role that they've taken is trying to make the same types of RECs available that corporates use to offset their emissions, make those available to you and I, and through our direct home purchases, right? And to align, kind of some of our values with the use of green energy, even if it can't be matched perfectly to our location, to ensure that there is a unique ownership to it coming onto the grid. But Mark, I'd turn it over to you to see if there's anything else you'd want to add on that side that's important.
Yeah, I'll give two examples, and I encourage folks to look directly at the source material from Google here for more details. But I think it's important to note One that, as John was just saying, about making RECs available that corporates have been buying for decades to households is a feature of the product that Google announced a couple of weeks ago, in that RECs from 2 projects that support Google's data centers will also be available to customers, right? And those will be in addition to what the data center is off taking in terms of its own needs for green energy and electricity, or green attributes and electricity. And then the second point, as Lauren alluded to, is something that I'm pretty excited about, which is this idea of carbon targeted procurement for new projects. So going beyond those 2 projects that Google announced as part of Nest Renew at launch, there's language that they've shared around where they're going to seek to put new projects to support the demands from new subscribers in a way that they can reduce the greatest number of emissions per megawatt hour and have the largest carbon impact in the grids that have the biggest issue with fossil fuels today. And so both of those ideas get back to this concept of tracing where it comes from and making sure that that attribute that a customer might sign up for is having as much of an impact as possible.
Thank you for that. How do you guys see rooftop solar fitting into this puzzle?
Well, there's probably a lot of ways, and all 3 of us might have different comments. I'll jump in here. I mean, to what John was saying a few minutes ago, we would like every asset that either produces, stores, flexes, or uses electricity to be part of the grid, right? And to be an intelligent, piece of shared infrastructure that serves all of us in the end. And so, to the extent that we can think beyond just energy efficiency, deep energy retrofits, demand response, and into things like rooftop solar, perhaps coupled with storage, that just, again, makes more tools in the toolbox available to utilities, but also, potentially service providers who could integrate those assets into more comprehensive solutions for, for example, these neighborhood projects that might avoid a peaking power plant. So, going forward, I see a huge potential for every kind of household carbon-free electricity asset to play an important role in delivering the full set of benefits that we see from an example from services like Nest Renew.
Thank you. Another interesting question we got was, how does the opportunity for households to adopt EVs compare to that of a commercial fleet switching to EVs, particularly with taxis whose use is also decided by a household? And then the commenter noted that commercial fleets could be better at demand response too, as far as when they're charging EVs. Knowing that you guys are not our mobility team, does anyone want to take a crack at that one?
I'll jump in.
If not, I will, but you're probably better technical experts.
Well, I'll keep it short, right? I think my answer is it's both and, not either or. The vehicles we drive and make decisions about as individuals are really important, and not just reducing direct emissions, but also reducing congestion, which creates undue pollution, especially in otherwise disadvantaged communities. So we need to be thinking not only of the fleet vehicles, even though they perhaps might have greater economies of scale or easier integration, but also, at the edge of the transportation network, the vehicles that we put on our streets or in our garages every night also need to be a piece of this solution.
Yeah, and I'll just also add, the bottom line here is we're only talking about 40% of energy related emissions in the emissions that we chose to include in this analysis. So there's still a whole 60% of the economy that also requires serious emission reductions. And we have the power to influence a lot of those decisions as well. So limiting our influence to only inside the home is not necessarily what we're advocating for too, but we wanted to see how far this sector could go and what that opportunity looked like.
Excellent. Thank you guys for that. And keeping an eye on the clock, I think we have room for about one more question. So our apologies for anything that we didn't get to. But John, I'm going to ask you to close us out on a very interesting one. Can we save more money and energy if instead of a carbon credit system, we merely put an economy-wide price on carbon?
Oh my goodness, you left me with a hot one.
And you only have 5 minutes.
Yeah, no, the idea of a carbon price, of course, makes huge sense if we could, put a tax on the things that we don't want, like pollution into the atmosphere, especially if we take that tax and recycle it to actually solve the problem itself or to offset other taxes that we pay that are less constructive, right? The challenge is always the political economy of getting that working. I think the notion of paying for RECs is a little bit of it's kind of like a voluntary carbon price that you're exacting on yourself, saying I'm willing to pay a little bit more for my electricity to ensure that I'm getting what I need right now, that is green aligned. And at least to begin with, I think what this product that Google has created is doing is allowing you to participate in a way where you're volunteering to support that without the government leadership or the regulatory leadership that's required to put the price on and help us logically price everything into every decision in the economy. So I would love to see some real price on carbon emerge here. We believe at RMI that the time is ripe for a voluntary price on carbon to flow through the markets quickly, because there are so many corporations in particular that are leading and have committed to net zero or climate aligned targets and need ways to actually verify and showcase their own reductions. That said, until that point that we get some form of voluntary moving to compliance market, having a price on RECs is a helpful way for us to do our part and to keep track of it in accounting. So with that, I'm going to turn it back to you, Rebecca. Hopefully our audience found that as a satisfactory answer. If not, we're happy to follow up on these or any other questions that you have. We are deeply grateful for your participation today and for your alignment and support of our mission overall. Back to you, Rebecca.
Excellent. Thank you for that answer, John. And sorry for dropping the most complicated one at the very end, but definitely appreciated getting your thoughts on that. And extending that thank you to everyone who joined us today. We are always really excited and energized when people join us on these webinars and care about the things that we care about. I'd also like to thank all of our donors who joined us today, whose support really makes all of the work we do possible. If you'd like to go deeper, please feel free to download the report. It's available on our website and we can share the link. And then also feel free to reach out to Lauren and Mark, who are our two primary authors, who would love to answer questions if you have further ones. So thank you again to everyone who is on the line today. I hope you all have a wonderful weekend.